Good evening guys, sorry for the robotic voice, something happened to my recording for this lecture so I am recruiting technology to help me give this lecture this week. I hope it's easier to understand than my real voice. Anyway, let's get started. This is Lab 10, the next principle of HACCP and HARPC, corrective actions. Let's get the important administrative matters out of the way first. By now, you should have completed the quiz, as it is due today. There is going to be another one, but as I've said in the live lecture, don't panic. The next quiz will be ready for you on November 30th, after our last live lecture, and will be due on December 7th. Speaking of December 7th, your projects are due then, as the first group will present starting from that day. Your group schedules are shown here. As you can see, all three groups now have their designated slots booked. If there are any issues with this scheduling, you will need to work with each other prior to the presentation deadline to switch time slot. I will send you a Zoom link for the presentation, one for each group. Do not use the lecture link, it's only there because it was set to repeat for every week. The link will be emailed to you. You will all need to submit drafts of your projects on December 4th or 5th. The 4th is preferred. Don't worry about completion, I just need to see a sample of your project. How you share it is entirely up to your group. I like Google Drive myself. Next, I must remind you to do course evaluations. I don't know much about the student side of it, but I know you can access them on Get. We encourage you to fill this out, as it helps improve CSULA courses. The only remaining item I believe is your final. Final exam week is December 13th to 17th, so my goal is to have that exam ready for you either the weekend before or at latest, on the 13th. Regardless, it will be due on the 17th before midnight. I should have your final grade by December 22nd. Because, well, that's when it's due. Alright, now that those things are out of the way, let's get ready to talk about the course material. We should do a quick review of internal auditing and monitoring procedures, so that's first. Then, we'll cover corrective actions. There are two lessons relevant to corrective actions. I actually introduced the concept to you when we covered internal auditing. We also covered internal auditing in weeks 7 and 8, but I digress. Internal auditing checks to see whether your company is complying with its GMP programs, and to identify areas that are not compliant, which we call deviations. These deviations require corrections. With regards to HACCP itself, we most recently covered critical limits and monitoring procedures. These are the HACCP principles which focus on defining the means by which we measure whether critical control points or preventive controls function. What happens when a monitoring procedure detects that a critical control point has exceeded its critical limit? Well, this is also called a deviation. If the deviation is minor, a correction much like one would make in an internal audit may suffice. However, in other cases, more drastic action is needed, which requires further intervention in food production. For example, you may need to determine what caused those deviations and reduce their occurrences, or worse, conduct a recall. Hence, the importance of the principle of HACCP I am introducing to you today, which is establish corrective actions. Okay, I'll start us off in a bit, but I need to tell you guys something. I have a little bonus for you, by the way. If you need resources for monitoring procedures, check out your textbook, pages 340 to 344. There's some good stuff there for you to review if that principle of CCP isn't quite clear to you yet. There are also some decent templates that you may derive some of your documents from. For example, there is a training log in there, as well as corrective action and thermometer monitoring templates. I do not remember the page numbers, however. Now, back on our main topic. Here is the official definition of corrective actions. They are the measures to be taken in the event control is lost at a critical point. Your book only covers HACCP, so I'm paraphrasing from the book's version. I suppose you could say in the event a CCP or a preventive control is found to be out of control. Let's go over the terms for the different types of corrective actions. Some of these, you should recognize. A correction is any action taken to immediately fix a deviation or a food safety issue. Corrective actions also fix deviations. However, corrective actions are a more formal process, and in addition to the immediate fix, further intervention is taken to prevent the deviation from happening again in the future. Of course, they don't have to be perfect. They rarely are. But corrective actions are conducted such that any food affected is aggressively taken into control by a quality team. To illustrate correction versus corrective action, imagine a production line where you are QC technician. Let's say you guys were making yogurt, and your job was to check the cups that come out of the filling station. You check for stuff like the weight of the cups, the contents of some of the cups, the color of the yogurt, etc. If you had a few units of yogurt which were too heavy or too light, the correction would simply be to throw those units away, and adjust the filling station's fill level. That's a correction. You'll need to make note of it, but it isn't serious. Corrections like these, as you can imagine, are quite common, and do not require you to take complete control of the entire production lot of food and determine whether or not you need to remove them. Now, on the other hand, imagine that you found a piece of metal in one of the yogurt cups. This is where corrective action is needed. You will need to stop the production line, figure out how many cups might have been impacted, etc. In this example, you'd check how many cups passed through the line since the last time you checked the contents of the yogurt, get rid of them, and check the metal detector. Then you can restart production. When you counted the cups that might have been affected, this was the investigation portion of the corrective action. And removing those cups was the preventive action, as getting rid of them eliminates any chance of missing contaminated units. So that's the difference between correction and corrective action. Many companies now expand their corrective actions to an entire program, called Corrective and Preventive Action, or CAPA. Here is what CAPA changes. First, CAPA includes corrections and corrective actions for quality issues as well as food safety issues. Quality deviations even have their own name, nonconformances. CAPA programs also include elements of customer service and complaints handling. If you complain to a large corporation's customer service line about its product, you can bet that if the issue is related to the product itself, it will be forwarded to the QA team for investigation. In fact, it's a key part of a QA manager's job. You yourself may deal with CAPA if you end up working in QA. I myself am part of the CAPA team at my company. I am not the main investigator of product issues, but I was the person who designed the CAPA records database using Microsoft Access. Alright, so we distinguished corrections, corrective actions, and CAPA. Let's move on to the procedure of a typical corrective action. Actually, it would be more accurate for me to say the typical flow of a corrective action. I'll elaborate. What I mean to say is that there are many corrective actions out there, but they all have 4 key things in common. These 4 things constitute a corrective action. First, the cause needs to be identified. In other words, investigation is needed. The QA team must be able to identify their problem and its potential sources, and there are ways to do that. More on that later. Second, product disposition, which is the amount of product affected and its status, must be known. This could involve identifying either the amount of product in pounds, i.e. during production, or identifying specific production lots, for finished products, or even the number of units produced over a certain time period. Third, the corrective action must be recorded. Yes, many corrections are recorded too, but they don't always have to be. Going back to that yogurt example from earlier, it's impractical to count how many units you threw away during production. It is sufficient to just make adjustments to the equipment based off of the information you obtained from the units of yogurt that you threw away as long as you performed your QC measurements properly. However, if the line must be stopped, that implies that your findings indicate that the batch is defective to the point of affecting food safety. Any fixes made constitute corrective action, and they must be written down in detail, and a procedure, if any, must be followed strictly. Keeping good records on your corrective actions is very important, and we will get to why when we talk about verification and documentation. Last, but definitely not least, the food safety program and CCP plan may need improvement. Keeping good records on your corrective actions is very important, and we will get to why when we talk about verification and documentation. Last, but definitely not least, the food safety program and CCP plan may need improvement. You'll see some of the ways QA teams approach problem solving of this nature at the end of the lecture. You'll need to have a team ready to address COPPA-related issues, and in some cases, issues which may prove even more urgent, and thanks to the additions I mentioned previously, it often includes office staff like the VP and CEO. This is called a crisis management team, and every major corporation has one, or at least some variant of it. Such teams actually focus on food safety incidents that expand beyond a typical HACCP plan, such as food safety issues that arise during a natural disaster, or the discovery of regulatory violations, and deliberate bacterial contamination. However, they also handle the recall of products, lot tracing, cooperating with regulatory agencies, and relaying explanations of the issue to the media. A crisis management team can handle these while minimizing the damage to the company's reputation. Therefore, while the crisis management team does not always handle day-to-day operations in food production, they are still a very important part of a food company's system for handling food safety emergencies. These teams are very helpful. You may have to support crisis management teams or at least be part of one yourself. One way you can support them is by gathering information. You can interview customers to get information on what might have caused them to get sick. This isn't necessary for every customer complaint, of course, but it is critical to do this if a foodborne illness is traced back to a product sold by your company. First, you should ask for public health or medical statements. Public health departments gather this kind of information all the time, and while doctors cannot share patient information, the patient could provide doctor's notes if they feel comfortable doing so. Regardless, your goal is to get the following. 1. When they bought the items. 2. The lot code or expiration date. 3. How the customer stored the product. 4. How they cooked or prepared it. 5. How much of it was eaten. 6. What symptoms they had, and 7. What other things they ate. When you have this kind of information, it will help you do two things. First and foremost, if there is no recent outbreak associated with the food in your city, this information should be reported to them. Second, this information could help you determine whether your company was at fault for the incident. Sometimes, it is out of your company's control. There are times where your company has done everything correctly, but the product was mishandled. Your team can even make a decision to recall if information from these interviews suggests that the source of their illness likely coming from the product that your company is making. Speaking of which, I believe that is the next slide. My mistake, it's the slide after this. We need to discuss product disposition first. Determining product disposition requires knowing the condition of the products themselves, and specifically, which batches, or lots, have that problem. You can get that information from several sources. The defects and the lots affected can be provided by customer interviews. Inventory systems are great for determining whether certain lots of raw materials were added to some production lots. For some problems, it may be as simple as checking production records, albeit it can still be a lot of work. I said it was simple, not easy. Either way, once the defect and lot number of affected units are known, action can then be taken. We'll get to recalls in a bit, but here are 4 other common corrective actions. The first is rejection. This corrective action happens before or during a production cycle. A shipment of raw materials or a batch of in-process products is rejected when it fails to meet your company's specifications. So if, say, some raw chicken you bought smelled really sour and rancid, you would reject it by sending it back. For in-process products, I refer you back to the metal and yogurt example from earlier. Another corrective action is an adjustment, or changing parameters in a CCP/preventive control to regain control. You could argue that this is a correction, but in some cases, like temperature, adjustments must be documented for regulatory reasons. The standard corrective action for malfunctioning refrigerators and freezers is to move the food to another compatible storage unit, so that the malfunctioning fridge/freezer can be fixed. You could call this corrective action movement. Another corrective action that you can take for food that is still being produced is to reprocess it. Perhaps it wasn't cooked for long enough, or an additive wasn't added to the batch but needs to be. Relabeling is also reprocessing. Here's a corrective action you should all be familiar with already: recalls. Recalls are a last resort option for correcting food safety issues. They are very expensive and a lot of product goes to waste, but sometimes it is necessary. There is a lot that happens during a recall, but generally speaking, this is how it goes. 1. The hazard is identified. This is needed to assess the level of risk. The FDA designates Class 1 recalls for high-risk hazards. These must be made public. The FDA doesn't give specific examples for the recall classes in its guidance, which I'll upload to Canvas later, but it's based on the assessment of the likelihood of illness or injury, and whether said illness/injury is permanent. Anyway, back on topic. 2. The amount of product affected. You will need to figure out how many production lots have been rendered unsafe by the deviation. In other words, assess the product disposition. 3. You must notify your business customers. Every company must carefully record to whom they have sold product, and this is one of many reasons they do this. In the event they must issue a recall, they must reach out to all of the businesses who bought product from them. 4. The company and its customers must take control of the affected products and prevent them from being used. This usually means giving instructions to your customers on how to deal with the product and making sure that they acknowledge it. 5. All of the affected product must be either reprocessed or destroyed. I must emphasize that it is never enough to simply throw it away. Although not common in the US, there is always a risk someone may try to continue selling the product. The affected product either needs to come back to your facility for reprocessing or damaged beyond recognition, to keep it from potentially harming a consumer. Any of you familiar with dumpster diving? This prevents divers from selling tainted food. Every company must carefully record to whom they have sold product, and this is one of many reasons they do this. In the event they must issue a recall, they must reach out to all of the businesses who bought product from them. I've had to do this as a customer once on the distribution side. A sauce manufacturer reported lactic acid bacteria contamination which was causing their bottles to explode. I signed their notice, stated what we did, and provided a receipt showing the actions we took, i.e. taking control of the product, making sure we had the right lot numbers, and then scheduling to have it picked up by a company that specializes in product destruction. It is a very fast-paced process, so hopefully, you have a good leader to guide you through your first recall. Time is of the essence when it comes to recalls. I mentioned sending out recall notices. Here is a typical consumer recall notice, courtesy of Safeway. There's no fixed format to a recall letter, but it does need to contain what I've listed on the right. We discussed most of it already and I'd just be repeating myself. So let me just talk about two unique points here. First, since this is a consumer-side recall notice, Safeway is reporting the regions where the recall applies to. Safeway could have also listed the specific store locations affected, but with so many locations, it seems to have made more sense for them to list the general municipal areas. Second, many corporations have separate communication lines for the general public, news media outlets, and industry business partners, so the appropriate contact information should be listed on the recall notice. Safeway provided a link to the FDA, which is technically valid as the FDA always provides the media contact phone number provided by the company with each recall notice. We should talk about how to write corrective action reports next. You had a taste of that with corrections in the internal audit, but there's slightly more to the process with more formal corrective actions. Again, the format isn't fixed. It only needs to meet these requirements, which should look familiar by now. You just need to know that you also need to describe the deviation in detail, record the time the deviation occurred, and in some cases, estimated times for completion. Don't forget that someone with some level of authority in the quality department must also sign off on these corrective action reports after you have completed them, most often your boss, the manager, but a supervisor could do it, too. Here are two decent templates, and you can find them on the page numbers listed on this slide in your textbook. Okay, now for corrective actions analysis tools. So for some corrective actions, an assessment of possible areas for improvement of the company's HACCP or HARP program is warranted. Some chronic issues continue to persist. The underlying cause or causes of the chronic issue will need to be identified, and this is done using a technique called root cause analysis. These are a series of analytical tools and problem-solving methods designed to diagnose quality issues. They are very different methods, but the root cause analysis tools all seek the underlying cause or causes of the problem, the fixing of which would have the most impact on improving the system. And in turn, this improvement would do the most to prevent the repeat deviation or non-conformance from reoccurring. It works by digging deep. Finding an immediate cause of the problem is never enough. Finding the most important factors is key. So there are, I believe, 7 RCA tools, but let's talk about the 3 most important ones. This first one is a Nishikawa diagram, also called a fishbone diagram. It's named both after the engineer who invented it, and its shape. It functions basically as a tool for a brainstorming session. You want to split your production process into 6 cause and effect relationships. The effect is the issue at hand, and the 6 causes are measurement, materials, methods, environment, manpower, and machines. Your team lists all issues that for each component, i.e. not enough workers for manpower, maybe unreliable suppliers for the materials, etc. For these issues, the causes for those must be discussed as well. The way it was explained to me is basically, you must keep asking yourself, why do we have this issue? Then, when a reason is found, asking why again, rinse and repeat, until ideas are exhausted. This actually complements the next RCA technique, the 5 whys method, as that method runs almost entirely on this mechanism. Anyway, the goal is to find something wrong with the way the company is organized or the way it operates in production, and targeting that for improvement. This RCA method is quite popular, as it helps the QA team develop a big picture of everything that happens in the facility, and great effort is taken to account for everything happening in the facility, not just things directly tied to food safety. Here's an example of a fishbone diagram used for cookie manufacturing. Judging from the analysis that this team did, it seems that the best solution is to provide more resources, management incentives, and to change cookie machine settings. True, poor management was listed as an issue too, but simply firing the managers will not really fix the underlying problem at hand. There just aren't enough tools, incentive pay, or training sessions. Maybe scheduling change would help, too. Here's an interesting technique that is used in quality, the 5 whys method. It's a technique created in Japan actually in the 1800s, I believe by the father of the guy who founded Toyota, actually. Anyway, here's how it goes. You gather your team and start discussing an issue at hand. Your first objective is to identify the problem. Once that's understood by everyone, your next step is to find the immediate reason for that problem. The key is to not stop there, so now, you must find the cause of that issue as well. Then you do this again, basically, your third why, and so on and so forth until you find a potential cause that gives your team the most control over the process. Most often, A fundamental change to the way your company operates to create the most impact on removing everything that could be contributing to the problem. If you want an oversimplified explanation of this method, imagine a kid who keeps asking you questions. When you answer their first question, they keep asking why and you find yourself answering them. QA must be that kid who keeps asking why. The difference, of course, is that when QA does it, this constant asking of why actually leads to something productive. That example on the right is used often for teaching this concept. Imagine you are part of a team responsible for maintaining the Washington Monument in D.C. You guys find that it's falling apart, i.e. paint peeling, bits of stone coming loose, etc. It's pointed out first that harsh cleaning chemicals are used to clean the monument, which is most likely causing the problem. That begs the question, why use harsh chemicals? Well, your team finds that they are needed for dealing with bird poop. That's actually great to know, because now you know why the chemicals were used, but pest control is not going to catch every bird dropping, now is it? What is attracting the birds there to begin with? Why are they there? Spiders. As it turns out, the spiders are serving as a source of food for them. Great, except that pest control is still needed for that. What about the spiders? What's attracting them? Well, they in turn eat bugs, specifically gnats, that are attracted to the monument. That's yet another pest that's going to be difficult to keep completely under control. So what's attracting the gnats? Well, gnats love light, and the lights are kept on at dusk, which happens after sunset, a few minutes before it goes dark. As luck would have it, gnats are most active around that time, and the lights are supposed to only light up when it is officially dark outside. The timing just hasn't changed from the winter, when it used to be dark much earlier. Aha! You guys found something in your day-to-day process which could be contributing to your problem. Changing the lighting schedule of the monument to 30 minutes later in the day so that the lights go off at 6 o'clock instead of 5:30 might help with the gnats. Sure, it's not guaranteed to work, but if it helps with the gnats, it will help with spiders too, which helps with birds, and it could reduce the need for harsh cleaning chemicals. Notice how many problems could be solved here. This technique is a very popular problem-solving tool across many industries, not just food. It forces a QA team to dig deep into the problem and find something fundamentally wrong with their procedures. There are some pitfalls, however. This technique is actually pretty useless for a company that does not keep organized notes, or have well-enforced standard operating procedures in place. This is because without good notes, your team is left to guess the reasons. Worse, the causes your team may identify may be completely out of your team's control, in which case the 5 whys method would need to be applied again, as the goal is to find something that your team can change. Despite that, it remains a very powerful, simple, and widely used tool. Admittedly, I haven't gone through a 5 whys session myself in the industry, but I know that it is used in larger companies. Here's a technique I've actually used myself. This is called a Pareto Chart. Not Pareto, I made that mistake myself, so no worries if that's how you read it. Have you ever made a bar graph? Of course you have. Well, Pareto charts have a twist. Pareto charts are bar graphs which are always ordered from highest to lowest, and the data is measured in terms of the frequency of each category. For example, if you are looking for reasons you received customer complaints, you'd use Excel to count. Let's say that you identified 4 causes: weight, sweetness, sickness, and container damage. You found that out of 100 complaints, 51 were due to container damage, followed by 30 due to sweetness, 10 due to sickness, and 9 due to weight. Put them in a table that looks like this, then sort them in order of most frequent to least, calculate the total number of complaints, and calculate the percentages for each issue. You might have also noticed a red line on that last graph. That red line represents the cumulative percentage of all complaints. For example, you could interpret from this graph that we could solve 81% of our complaints if we addressed only container damage and sweetness and nothing else. Anyway, you will need to add up the cumulative percentages at each point. This is pretty simple, just add up the percentages as you go down the column, like I did here. 51 plus 30 is 81, 81 plus 10 equals 91, and 91 plus 9 is 100. Here's what the Pareto graph for this table would look like. The beauty of the Pareto graph is that it helps highlight the most prevalent issues from a large subset of data, and it also communicates to your boss the benefit your team gains from focusing on more than one of these issues at a time. Imagine if our Pareto graph looked like the one in this slide. An ordinary bar graph might show these issues out of order or fail to highlight the benefit of addressing the top 3 issues at the same time, or worse, it would end up doing both. A graph like this is likelier to grab a CEO's attention, as it would show that they could help the company's reputation more effectively if they gave you enough resources to address multiple issues, rather than waiting until one issue stands out more. Here are some resources for you for studying corrective action in more detail. The FDA and USDA make their recall notices public, so feel free to look at those. The next few links talk about RCA tools. The YouTube channel is reorganized also. If you are interested in pursuing quality assurance in depth and want to focus on a more engineering-like role in that field, I would recommend getting a Lean Six Sigma certification after you've acquired QA/QC experience. It is highly sought after. Last, but not least, I'll throw up some handouts I found on Canvas for you to read if I haven't done that already. If you have any questions, feel free to email me. Otherwise, happy Thanksgiving.